Talking about the isotope. The chemical properties of an element depend on the number of protons and electrons inside the atom. So the chemical properties of elements depend on the number of protons and electrons inside the atom. So if a neutron or two is added or removed from the nucleus, if a neutron or two is added or removed from the nucleus, so a neutron is neutron so neutrons, if added or removed from the nucleus, then the chemical properties will not change. This means that such an atom will remain in the same place in the periodic table. For example, no matter how many neutrons we add or subtract from nucleus with 6 protons, that element will always be called carbon and have the element symbol C. Atoms which have the same number of protons, for example, same atomic number but different number of neutrons, different and therefore different mass number, are called the isotopes. So isotopes have the same atomic number but different number of what? Of neutrons. So they have the same but different number of what? Of neutrons, different and therefore different mass number, are called the isotopes. So we're going to look at the definition. Definition of isotope. Isotope of an element have the same number of protons, same same atomic number, but different number of neutrons, different number of neutrons, atomic mass. So the chemical properties of the different isotopes of an element are the same, but they might vary in how stable their nucleus is. We can also write element as E to A, where the E is the element symbol and A is the atomic mass of the element. For example, chlorine, which is in position 35, has an atomic mass of 35, 17 protons and 18 neutrons, while chlorine 37 has an atomic mass of 37, 17 protons and 20 neutrons. So they said, for example, chlorine 35 has an atomic mass of 35, which is 8, and 17 protons and 18 neutrons. So an isotope, they say, is an element that has the same number of protons but a different number of neutrons. So they say this chlorine has an atomic mass of 35. So 35 is what? Is atomic mass, which is a letter N. Here's the chlorine has an atomic mass of 35, 17 protons and 18 neutrons. And also another chlorine has 35, has an atomic mass of 35 and has 17 protons and 20 neutrons. You can see the difference. But the protons are the same, but the neutrons are the different between those two chlorine. In nature, the different isotopes occur in different percentage. For example, chlorine, which is 35, might make up 75% of all chlorine atoms on Earth, and chlorine 37 makes up the remaining 25%. The following worked example will show you how to calculate average atomic mass for these two isotopes.